Indian mathematics emerged in the Indian subcontinent from 1200 BCE until the 18th century. In the classical period of Indian mathematics, from 400 CE to 1200 CE, important contributions were made by the scholars like Aryabhata, Brahmagupta, Bhaskara II, and Varahamihira. The decimal number system in use today was first recorded in the Indian mathematics. Indian mathematicians made early contributions to the study of concept of zero as a number, negative numbers, arithmetic, and algebra. In addition, trigonometry was further advanced in India, and in particular, the modern definition of sine and cosine were developed there. Aryabhata is the father of Indian mathematics. He was a great mathematician and astronomer of ancient India. His major work is known as Aryabhatiya. It consists of spherical trigonometry, quadratic equations, algebra, plane trigonometry, sum of power series, and arithmetic. Before the end of the period of Sulbasutras, around the middle of the 3rd century BC, the Brahmi numerals had begun to appear. Here is one of the styles of the Brahmi numerals. These are the earliest numericals which, after a multitude of changes, eventually develop into the numeral from 1 to number 9 used today. The development of numerals and place-valued number systems are studied in the articles of Indian numerals. Harappans had adopted a uniform system of weights and measures. An analysis of the weights discovered suggests that they belong to two series, both being decimal in nature, with each decimal number multiplied by and divided by 2, giving for the main series ratios of 0.5, 0.1, 0.2, 0.5, number 1, 2, 5, 10, 20, 50, 100, 200, and 500. Several scales for the measurement of length were also discovered during excavation. One was the decimal scale based on a unit measurement of 1.32 inches, 3.35 centimeters, which has been called the Indus inch. During the century of 7th century AD, negative numbers were used in India to represent depths. The Indian mathematicians Brahmagupta and Brahmasputa Siddhanta discussed the use of numbers and negative numbers to produce the general form quadratic formula that remains used in today. Brahmagupta, he introduced rules of solving quadratic equations and for computing square roots, positive numbers, fortune, and negative numbers, depths. He wrote down rules that have been interpreted by the translators as a fortune subtracted from 0 is a depth, and a depth subtracted from 0 is a fortune. Brahmagupta also known as that the product of a depth and fortune is a depth. They were the first to make use of decimals and the number 0. They used negative numbers too, and they beat Pythagoras to his famous theorem. Indian mathematicians calculated the value of pi with a very high degree of precision and determined the circumference of the Earth and the timing of lunar and solar eclipses. In the 15th century, Kerala in the very south was home to a school of mathematics in which developed trigonometric functions. Despite originating independently of Chinese, and most likely Babylonian, mathematics, India achieved some highly significant mathematical breakthrough fairly early on, and the ancient Hindu symbol of a circle with a dot in the middle known as Bindu or Bidu, symbolizing the void and the negation of the self, was probably instrumental in the use of a circle as a representational of the concept of zero. The classical era of Indian mathematics from 500 to 1200 CE. The most famous names of Indian mathematics belongs to what is known as the classical era. This includes Aryabhata I, 500 CE, Brahmagupta, 700 CE, Bhaskara I, 900 CE, Mahavira, 900 CE, Aryabhata II, 1000 CE, and Bhaskara or Bhaskara II, 1200 CE. One of Aryabhata's discoveries was method for solving linear equations of the form ax plus by equals c. Here a, b, and c were whole numbers, and we seeking values for x and y in whole numbers satisfying the equation above. For example, if a is 5, v is equal to 2, and c is equal to 8, then x is equal to 8, and y is equal to negative 16 is a solution. In fact, there are infinitely many solutions, like x is equal to 8 minus 2m, and y is equal to 5m minus 16. Amongst other important contribution of Aryabhata is the approximation of pi to 4 decimal places, 3.14146. Some of the early and very significant developments of trigonometry were in India. Influential works from 4th to 5th century AD, known as the Siddhantas, of which there were 5, the most important of which is the Surya Siddhanta. First defined the sine as the modern relationship between half and angle and half a chord, while also defining the cosine, versine, and inverse sine. Soon afterwards, another Indian mathematician and astronomer, Aryabhata, collected and expanded upon the developments of the Siddhantas in an important work called the Aryabhatiya. The Siddhantas and Aryabhatiya contains the earliest surviving tables of sine values and versine. 1. Negative cosine values in 3.75 degrees intervals from 0 degrees to 90 degrees to an accuracy of 4 decimal places. They use the words of Jaya for sine, Kojaya for cosine, Utkrama Jaya for versine, and Utkram Jaya for inverse sine. Indian trigonometry tables showed that an angle of 1/7 degrees indicates triangles sides with a ratio of 400:1, meaning that the sun is 400 times further away from the earth than the moon. There were other major advances in Kerala that around this time. Citrabhanu was a 16th century mathematician from Kerala who gave integer solutions to 21 types of system of two algebraic equations. These types are all the possible pairs of equations of the following 7 forms: x plus y equals a, x minus 1 equals b, xy equals c, x raised to 2 plus y raised to 2 equals d, x raised to 2 minus y raised to 2 equals e, x raised to 3 plus y raised to 3 equals fx plus y equals a, x minus 1 equals b, xy equals c, x2 plus y2 equals d, x2 minus y2 equals e, x3 plus y3 equals f, and x raised to 3 minus y raised to 3 equals gx 3 minus y3 equals g. For each case, Citrobanu gave an explanation and justification for his rule, as well as an example. Some of his explanations are algebraic, while others are geometric.